as you know that we have done the work energy. So the topic is work, energy and power. And we have done the work energy, which is the work energy equation. And work energy equation, you know, we have done a lot of practice of this. So work energy equation is work done by the forward forces minus the work done against the backward forces, and that is equal to change in kinetic energy plus the change in gravitational potential energy. Since we are dealing only with the gravitational potential energy and kinetics, so that's why on the right side we write only these two changes, not the thermal energy or electric energy or elastic potential energy. So that's why putting these two energies only. But basically if we're considering all the forces, so then the change in all the energy we will consider on the right hand side here. Okay, and then yesterday we studied about its special case of work energy equation when no external force is acting. If no external force is acting, like no pushing, pulling force and no frictional or air resistances forces, so then no external force is acting. So this energy, this equation takes this form, that kinetic energy initial plus initial potential energy, that is equal to kinetic energy final plus potential energy final. So initial sum of the energies is equal to final sum of the energies, like energy is conserved. So this is called a law of conservation of energy. Okay, and then now the next part of this topic is power. So we will do that today. So power. What is a power? It is actually the rate of doing work. So rate of doing work. Energy is ability of doing a work. Like if we have energy, so we can do a work. If we don't have energy, we cannot do it. Means whenever we are finding the rate of something, so it means that quantity divided by the time taken for that is the rate. So it means that the power P, capital P is the notation for this. This will be equal to work done divided by the time taken. So P is equal to W over T, where T is the time taken to do that particular work. For example, if one person is doing a work, bringing some packet from one place to the other place, in this person is doing some work, holding a parcel, taking it from point A to the point B. So doing work on the parcel. So if this person is doing 300 joule of work and taking a time of 20 seconds, on the other hand another person is taking the same parcel from the point A to the same point B, and he is doing this work in 30 seconds. So 300 work because the distance and the force applied is the same, so it means that the work is done is the same. But he is doing fast, he is doing slow, so taking 30 seconds for that. So it means that the person who is doing the same work but in shorter time is utilizing more power. So the rate of doing work for this person will be more than the second person. So if this person is P and this person is Q, so power for the person P will be equal to 300 over 20, which is equal to 15, and power for the person Q will be equal to 300 over 30, which is equal to 10. Now 10 what? The unit. So the unit will be the watt for the power. Like work is joule and time is second, so it means joules per second. So this quantity is called watt. On the scientist name watt, it is WAT. So we denote it with capital W. So it means that here the person P did 15 watt work and the person Q did at a rate of 10 watt. Okay, so this is about the power. Now the important point is that this work, when we write P is equal to W over T, so this is actually the work done only by the driving force. Like if some car engine is doing a work, so the car engine is producing a driving force, so the work done by the driving force, not the net work done. Net work done will be the work done by the driving force minus the work done against the resistances. No, with that work will not take here. So this is only the work done by the driving force. Okay, so it means if we write this formula as power is equal to work done by the driving force divided by the time taken. So this is a better form of this formula. We don't consider the resistances here in this, or this is not the net force time, work done by the net force. No, it is not that, it is only the work done by the driving force, right? And then we can split this form into another form, which is power is equal to work is actually the force multiplied by the distance moved and then divided by the time taken. So here we can write it as F times S over T. So S over T is the speed. So it means this can be replaced with F times V. So power can also be found by force times the speed. Okay, so this is another form of this formula, that power is equal to force times the distance. But as we said that we only take the driving force under consideration, so F is the driving force only. Okay, so we can say that the better form for this will be power is equal to driving force multiplied by the distance moved. So this is a better format of this formula, and this is the better format of the power formula. Okay, when the work done by the driving force is there, so this is a better way. So this is a okay student, there is a mistake here in writing during my lesson. Actually this is power is equal to force times the speed, not S, it is V. So P is equal to F times V, and similarly here power is equal to driving force times the speed V. So it is not S, it is V. So kindly make this correction in my lesson, that here P is equal to F times Z and here P is equal to D times V. Thank you.